Welcome to Brain Vision.
So this is a bit more complicated in the sense that we're trying to find the moment of inertia about a parallel axis at a distance from from another axis through the center of mass. So essentially, we would use the parallel axis theorem. We'll say I parallel, so IP is going to equal I center of mass, the moment of inertia through the center of mass, plus md squared. So this would be the parallel axis theorem. And at this point, we know that essentially d is the distance between the axis associated with the moment of inertia through the center of mass, and then so basically the distance between that and IP, the moment of inertia through a parallel axis. So here we're going to write down I of a rectangular plate about an axis along the edge. And this is going to be equal to IP. So this would be IP equals ML squared over 3. And at this point, let's try to draw these figures. So we have figure A for part A, and we have, let's just draw a box. So this axis right here, this represents moment of inertia P. So this would be I sub P. And at this point, we can say that we can label this and say this is W, this is the width, and this is the length. And it's saying that for this axis, they're trying to find the axis needs to be lies in the plane, lies in the plate of the plane of the plate. So this would be axis lies in plane of plate through the center, and then parallel to the moment of inertia about the along an edge. And if you were to draw this, this would simply be the axis that they're talking about right here. And this would be straight, and we know that this distance right here, rather, distance on the other side here, this would be d. And at this point, let's draw the second figure. So figure B would be much like this one, except that here the axis rather needs to lie in the plate. It needs to be through the center. But now here it's going to be perpendicular to the moment of inertia about an axis along this edge. So when we draw this, it'll be apologize there. And this will be, again, our width, our length, and this is, again, our I sub P. But now the axis that they're looking for is going to be this right here. This would be our axis. And then this distance right here would be d. So At this point, we have drawn our two figures, and we can attempt to work. So the distance for figure A, we can say, is going to be the width over 2, and the length will be the width for A. And we know that the D for B will be the length over 2, while the LB will simply be L. We know that the ICM equals IP, and this time we have manipulated this equation. So now I of the center of mass equals the moment of inertia along an axis, along about an axis along an edge. So, and this would be minus md squared. At this point, we can say that ICM of A will equal mw squared over 3 minus mw over 2 squared mw squared over 12. Again, w denotes width. And ICMB would equal ml squared over 3 minus ml over 2 squared, and this is going to equal ml squared over 12. So these will be your answer for the solution. This is the solution to this problem right here. And that's the end of the solution. Thank you for watching.